Hello, geometry folks, and welcome to finding the volume of pyramids and cones. Today you're going to need your flip chart notes, a pen and a pencil, and a calculator. And we will get started. So we're talking about volume again. And so volume is how many cubes I can put inside my structure or my figure. So the volume of a pyramid is, here's my pyramid. If I want to find the volume of it, the formula is 1/3 the base or the area of the base times the height of the pyramid. Now we really need to be careful here because we have been working with a couple of different heights. We've been working with the slant height, and that height we need with surface area. But the height that we need for pyramids is our height inside our pyramid, from the base all the way to the top where the vertex of all those triangles meet. So the big B again is your base area, and your height is your height of your entire pyramid. Okay, so if you write that down in your pyramid notes, we will do a couple of examples. So first we want to find the volume of a pyramid, this particular pyramid. This looks like a hexagonal pyramid, so the base is a hexagon, okay? And we're going to round to the nearest 2 decimal places. So first of all, we're going to write down the volume. Volume is 1/3 the base area times the height. Now remember, this is the area of the base times the height of the whole pyramid. Okay? Now, let's just make sure that we know the difference between the height of the pyramid and the slant height. So if I were talking about a slant height, it would be like this height on the side, remember? But the height of the pyramid in this case is 8. So that would be all the way up and down right here. That would be 8 centimeters. Okay, so the volume is equal to 1/3 the area of the base. Now to find the area of the base, we need to know how to find the area of a hexagon. So I'm going to take this hexagon and bring it out here. You know, all the sides are 6. Okay, what else do we need to know when we're finding the area of a hexagon? Well, we need to know that we can draw a triangle here. So we can have our triangle, this is 3 because I'm going to cut it in half, so that would be 3. I need to find the height of that triangle, and I would know that all the degrees inside a hexagon would be 180 times 4. Okay, the sides minus 2 times 180, which would be 720. Divide that by 6, that would give me 120 degrees per angle. And then I'm going to cut that angle in half, and I'm going to have a 60-degree angle there. All right, so now if I'm standing here, I am going to do the tangent of 60 is equal to x over 3. And x would be, let me see if I can figure that out, x would be 5.196. Okay, so the height of the this little triangle within the hexagon would be 5.196. Okay, now what we do is we find the area of that one triangle. Okay, so we're going to do the base is 3 times 5.196 divided by 2. But remember how many of those triangles are within a hexagon? There are 12 of them. And then times the height of the pyramid, which would be 8. Okay, so we're going to take 3 times 5.196 divided by 2. I get 1/3 times 7.794. Times that by 12, then times by 8. If I put that in my calculator, I get 249.41 centimeters cubed. That would be my volume of this hexagonal pyramid. Okay, let's try another one. We want to find the volume of this. Oh, we know the volume of this pyramid. Now we want to know what the height is. Okay, so what we need to know is what the formula for volume is. Volume is 1/3 the area of the base times the height of the whole pyramid from the bottom of the base to the tippy top, or where the vertex where all triangles meet. Okay, so volume is 56, okay, times 1/3 the area of the base. In order to find the area of the base, I got to know what the base is. The base is a triangle. So I actually have a right triangle here. I have a 90-degree angle here. I got 6 meters here. I don't know what that is, but I know this side is 10. Looks like I'll do the Pythagorean theorem. So 10 squared equals 6 squared plus x squared. 10 squared is 100, 36. I'm going to subtract 36 and I get 64 equals x squared, x equals 8. So this x right here that I was trying to find is actually 8. Now if you don't want to use x and you want to use y, that's fine. Just make sure you don't mix up the x values depending on the variable you use. So we found that this is 8. So the base of the triangle is 8. So the area of the base would be the area of a triangle, which is base, which is 8, times height, which is 6, divided by 2. Remember, the area of a triangle is base times height divided by 2, times the height of the whole thing, which is 8, which is x, excuse me. We could call it h if you wanted to, or you could call it x. I'm going to call it x since it was called x here. I take 1/3 times 8 times 6 and divide that by 2, and I get 8x divide by 8, and x is equal to 7 meters. So the height of this triangular pyramid is 7 meters. Okay, so that is pyramids. Now let's take a look at cones. So the cone formula is exactly the same thing. The volume is 1/3 the area of the base times the height. We just so happens that the area of every cone, the base of every cone, is pi r squared. So this is the area of the base, which happens to be a circle of every cone. All right, so it's still the same thing, but I'm going to go ahead and plug in pi r squared because I know that the area of a circle is always pi r squared. So let's go ahead and do an example here. Find the volume of this cone. Round to the 2 decimal places. All right, I'm going to say volume is equal to 1/3 the area of the base times the height. The area of the base is pi r squared. So volume is equal to 1/3 times pi times radius. The radius is 5 squared times the height of the pyramid. Well, the height of the, or excuse me, the height of the cone. The height of the cone is from here to here. I don't know what that is, but I know the slant height is 13. I don't want the slant height. I want the total height. So what I'm going to do is I'm going to take this triangle, which is 13. I don't know what that is, and this is 5. And I am going to find that height by using the Pythagorean theorem. So I'll have 5 squared plus x squared equals 13 squared. 25 plus x squared equals 169. X squared equals 144. 169 minus 25 is 144. Square root both sides, and I get x equals 12. So this would be 12 feet. All right, So then I'm going to plug that in. Volume equals 1/3 times pi times 25 times 12. And if I plug that into my calculator, I would get volume equals 314.16 feet cubed would be my volume. Remember, this is the height of the total cone, not the slant height. Okay, be careful with that. All right, let's do one more. Find the volume of this complete solid. Okay, so I've got a couple of things happening here. I've got a cone and I have a cylinder. So I have to remember from yesterday what the area of a cylinder is, or what the area of what the volume of a cylinder is, excuse me. So I would say the volume of my cone plus the volume of my cylinder would make the volume of this complete picture. So I'm going to do volume of my cone first. So the volume of my cone would be 1/2 pi r squared times height. 1/3 pi times 2 is my radius. There's my radius right there. Times my height. Now, it doesn't look like I have a height. It looks like, again, I have a slant height, but I don't have a height. So I need to do a triangle again. This would be 7, 2, and I want to find the height of that cone. So I'd use the Pythagorean theorem. 49 is equal to, well, 7 squared is equal to 2 squared plus x squared. 49 equals 4 plus x. 45 equals x squared. Square root both sides, and I get x is equal to 6.708. So my height is 6.7082. Okay, and then I need the volume of the cylinder. Remember, the volume of a cylinder is base times height. Okay, and the base for a cylinder is pi r squared times the height of the cylinder. So this would be plus pi times the radius is still 2, so 2 squared times the height is 5. So if I find the volume of the cone, I would get 28.099. If I find the volume of the cylinder, I would get 62. Oops, I'm sorry about that. Let's erase that. It would be 62.83. Add those together and I would get 90.93 inches cubed would be my volume. All right. So today we're talking about volume of cones and pyramids, and we might still need to know how to find the volume of cylinders. Thank you for taking good notes, and we will be back to practice them in days to come.